Kia ora and welcome. This is the second in our mini-series of 4 webinars, which will showcase some of the recent developments in remote sensing technologies and how we use that to apply that to answer questions for policymakers, councils and landowners. Stella Ballas has been part of a team that has developed and improved methodologies for analysis of land cover of every description over the years. Most recently, she's worked to build a better understanding of what winter forage crops look like from satellite imagery and other data. She will provide a brief history of our winter forage mapping projects and some results from recent work at national and regional scale. I'll be back at the end to manage our Q&A session, so don't forget to put your questions in the chat box as soon as you can. It's now over to you, Stella.
Okay, thank you, Christine, and good afternoon, everybody. I hope some of you were able to be here this morning to listen to my colleague Dave Pearman's introduction to remote sensing, and I will move on from there. And I'm speaking about our winter forage crop mapping that we do from time series of satellite imagery, and I'm speaking on behalf of our team, predominantly Heather North, Alexander Amies, and David Pearman.
Stella, can I just ask that you put it on slideshow so that we get the full slide on the screen?
Sure, sorry, thank you.
Lots of people still looking on small screens these days. Thank you.
Oh, wonderful. Okay, so starting off with, what do we mean by winter forage? Well, we're talking mainly about the brassica crops, the kales and the rapes and what we used to call chaumolia, also swedes and turnips. More recently, quite a lot of people are also growing fodder beet, and a lot of farmers also use cereals such as oats, barley and wheat as winter forage crops, as well as intensively grazed pasture. Sometimes the winter forage crops are left as an entire paddock and stock are let out into the paddock to graze at will, but more often than that, paddocks are strip grazed and a temporary fence is put in and the stock graze up to that fence and graze right down to bare ground level first before somebody comes and moves the fence for them. Now, we've been developing our winter forage mapping for a number of years. It came out actually of our general land cover mapping that we were doing, often in cooperation with Environment Canterbury. We were looking at land covers, crop types and crop timings, and we started looking both at summer and at winter cropping. And as time went by, people have got more and more interested in the issues of what happens with bare ground in the middle of winter and its effects on water and water quality and leaching, etc. And the need for looking at our land cover maps within our winters has become more and more important. So we started our winter forage maps with some initial trials in Southland, and that's where we first started to develop and test our methodologies. And at that stage, we just used a small test site around Gore Mataura, and we were using commercial satellite images from the Spot satellite. Marvelous system because it had a 10-meter spatial resolution and a shortwave infrared band. The shortwave infrared band is really useful when you're looking at vegetation. And with these initial trials, we looked at single date versus multi-date classifications, and we looked at whether we could actually work out when paddocks were in different states through the winter. In our first trials, we were getting very good separations between brassicas and fodder beets and being able to separate these from pasture. Because we were working in the far south of New Zealand, we were a little bit challenged by the sun elevation angles, which get way down almost to single figures in those days, and some of our radiometric calibrations just didn't like working at such low levels. And you'll see there at the bottom of the slide some of the land covers that we were classifying then. And when you look at some of the results I'll show you later on, you'll see that we've now expanded and have much more detailed land cover when we're mapping it. Since we started, Oh, there we are. Since we started with these trials, we've gone on often mapping a single region at a time. After the original Southland trials, we did a map of the full Southland region the following year, 2014. We repeated that for them in 2017. We've also done 2 different winter forage maps in Canterbury and 2 in the Hawke's Bay as well, one of which was done last year, and we tried to do what we called a so-called fast map and get the imagery out to the users before the end of the winter forage eating season. In 2018, we were contracted by the Ministry for Environment, and they wanted to have a look at the winter forage in the hill country of all of New Zealand. They were defining hill country as over 7 degrees, and they wanted to see how much winter forage was there turning into bare ground during the winter to get an idea of the potential risk for soil erosion from these crops. We followed that with looking at all the hill country bare ground for 2018 by including the bare ground that comes from forestry as well. And this work was published in the Journal of Environmental Management, and I've put the reference to that work there. A lot of the other work that we've done for regions has actually been done on commercial contracts, and the results are available in reports that you can talk to the councils to see if they will share them with you. And at the moment, we're in the middle of mapping all the New Zealand agricultural land winter forage in 2021, and we're about to start work on a 2022 winter forage map as well. As we've been working our way through these winter forage maps, we're gradually developing and improving our methodologies. Now, if you were here this morning, you would have heard Dave talk about the satellites that we've used through time. This is our main go-to satellite now, Sentinel-2. Some of you will know quite a bit about it, but I'll just go through some of its fabulous qualities. First of all, there are 2 Sentinel-2 satellites with 10-day repeat cycles, so we can get an image every 5 days. It's got 13 spectral bands, and it has a good resolution of spatial resolution of 10 meters. And best of all, it's got this wonderful wide swath of 290 kilometers. So when you get a good day, you can get coverage of a whole region in one hit, and you don't have to fiddle around mosaicing different images together. There are 5 different passes that cover all of New Zealand. In actual fact, 3 passes basically cover all of New Zealand. It's just the very, very, very westernmost part of Fiordland that gets missed out and needs an extra pass for that, and the very, very, very edge of the east coast of the Poverty Bay region. So most of our satellite imagery that we use for winter forage mapping is processed automatically, and these processes are run on the National eScience computer infrastructure. As Dave was talking about this morning, there's a lot of pre-processing done so that all the imagery is ready for analysis. Basically, here's one we prepared earlier. All the calibrations and corrections and the cleaning off of all the clouds and shadow and the topographic corrections, they're all done as part of this analysis ready process. And then other processes that run on the supercomputers with automated processing that are involved in the winter forage work are paddock boundary mapping, the spectral classifications, and also a series of multi-temporal rules are applied from our classifications so that we can identify the winter forage paddocks. So I'll take you step by step through the main processes that we use for our winter forage. First of all, we have to choose the images that we're going to use. Now that we've got so many images taken over New Zealand, we can actually get quite fussy about them and throw out the ones that are fairly cloudy and just keep the very best. Our winter forage sequence mapping runs from March to mid-September of the mapping year. And when we're producing paddock boundary maps so that we can map our paddocks, we extend this back into the previous year so that we can get a lot of land cover changes showing up in the paddocks, which helps us to determine the boundaries. As you can see here, even with 5-day coverage, we can still go whole months in some parts of New Zealand with no suitable data to use. Having selected all the imagery that we're going to use, the next thing to do is to apply some additional masks to the data. And here's an example of Otago, and it's hasn't had its agricultural mask applied to it at this stage, but it has had a cloud mask applied. And if you look at the coastal areas, especially in the northern parts of the coast, you'll see where the cloud has been masked out. To produce these masks and take out the non-agricultural land, we use the different classes of the land cover database. Here's an example of the Taranaki region. This is the data that we're using at the moment to map the winter forage in 2021. This is our sequence of images. They've had the cloud and the non-agricultural land masks applied. The full sequence here would be used for paddock boundary mapping. Only the sequence in the lower line here from March to August is the one that we would use for the winter forage mapping. Having got our data ready, we then need some ground truth to tune our classification. So what we've been doing is going out with a GPS and mapping different paddocks in the different regions that we're working on and identifying the crops within them. We're looking often for the major crops of kale and fodder beet, but these days we're also finding mixes in some of the paddocks too. And I don't think the farmers are doing this to confuse us. They're doing it because it's quite useful sometimes to put in a mixed crop of, say, pasture and clover with brassicas as well, and the brassicas grow up. And then you can let the stock into the paddock and they scoff all the brassicas, eat a bit of the grass, and then you can take the stock off and let the lower pasture grow on, and then let stock back into it again. And this is one of the ways that people can cut down on the possibility of the ground becoming bare for any period of time. I'm not quite sure what the people were doing mixing up kale and fodder beet together. That's the only time I've ever seen that. So the next step in our winter forage mapping is to make a map of all the paddock boundaries. And we do this so that we can treat each paddock or crop parcel as a whole object for the subsequent analysis that we're carrying out on the work. And this work's been published too by my colleagues Heather North and David Pearman, and this was published in 2019. Once the methodology's been applied, the paddocks are converted into a vector GIS format, and then we also burn the roads into that layer too. And if you look within the image that I have on the screen here, you'll see some little wee pieces in here. Now these are basically things that come up during the methodology, and they're taken out before we create the final paddock boundary map. And the next step in winter forage mapping is the spectral land cover classification. At this stage, we work on a per pixel classification of all the images that we've got in our time series from March through till April or to mid-September. And we don't just look for the winter forage classes at this point. We're also looking for pasture, and we're also looking for bare soil. The example here on the screen is a small piece of Otago, and the image was taken in April of 2018. And this particular band combination that we're using here uses red light, blue light, and shortwave infrared light. And in this combination, the brassica paddocks show up as blue. And you'll see all these blue paddocks here. When I swap to the next slide, we're going to see the same image, but it's taken in September of the same year. Here it is. So the next step is to use a rule-based classification of all the winter forages and pastures that we are mapping. Basically, we're looking for two things. We want to look at a spectral land cover class that identifies as a forage type or an improved pasture at the beginning of the winter forage season. And then in the later imagery, we like to see that it's changed to bare soil in the winter or the early spring. If we have a good image sequence, we'll be able to see both of these things, and we'll have very good certainty that we're looking at winter forage. Sometimes we're less certain because we don't have such a good image series. And you see these paddocks here, which were bright blue in the April image, have now been all eaten away, and they're looking, and they've gone to bare ground. So looking at the rule-based classification in a little bit more detail, there are two things that we're doing here. First of all, we're doing a per pixel analysis through the time series of images. We're trying to look at the date in which the pixels first had vegetation in them, and the date at which they became bare, and then sometimes a date at which they may have become vegetated again. And we're also trying to determine what was the dominant land cover in the vegetated period of that winter forage season. And then after that, we're doing a per paddock analysis where we've applied our paddock boundary mapping and imposed the GIS paddocks over the pixels. And then from a per pixel assessment, we can determine the dominant winter land cover. This table here is showing the current classification rules that we're using for our winter forages and intensively grazed pastures. This is what we're applying to the national 2021 winter forage mapping that's underway at the moment. And you can see we have a variation in the certainty levels that we can apply to the identification of our winter forage paddocks, depending on the amount of evidence that we've got. We're happiest when we can see the dominant winter land cover and we can definitely classify whether it's a brassica or a fodder bed or a cereal. And that subsequently during a good time series, we can see that it's gone to bare soil at the end of the season. There are times when we're not sure what the winter forage is. We're pretty sure it's a winter forage, but we're not quite sure what, and we can see it going bare later, and that's still reasonably good evidence. And then we have other cases where we're giving it a lower certainty level. They're probably still winter forage crops, but we just don't have as much evidence. We may not have had data towards the end of the season, or we may not have been able to observe things becoming bare, or we may have just seen a significant drop in the amount of vegetation within a paddock without seeing any other evidence, such as strip grazing. Having done all our spectral land cover classifications and identified all our winter forages, all the automated work, we then have to go back to looking at a manual system for validating the paddocks that we've done. And we've got a nice little tool called Map Accuracy, where we can put all the paddock polygons that we've identified into a simple little time series tool, and it organizes them in sequential order, and you can very quickly go through with a series of keystrokes and agree with the classification that we have got a winter forage paddock, or sometimes we've got some false positives in our data. These often caused by a little bit of shadowing where the masking wasn't quite right, and sometimes very fine cloud can interfere with the classifications as well. Here we've got a typical example of a paddock starting off in March in the top line. Here, April, in both of these months, we've got a full canopy cover of a brassica crop. Once we get down here, we've got into, in this case, July, and you can see that most of the crop has been eaten. Late July in our next image, and then once we get to August and September, the whole paddock has become bare. So this is a paddock that we would agree that is valid through our map actually, and leave it as a valid paddock. Right, what do some of our results look like? Well, this is an example of the hill country winter forage mapping work that we did for the Ministry for Environment a couple of years ago. I should point out that all these green pieces here aren't actually all contiguous. It's just the scale of the map that I'm showing you here that makes it look like they're all joined together. Our mapping of all the hill country winter forage showed that most of the hill country areas in New Zealand that we use for winter forage were in the places that you would expect it to be: Southland, Otago and Canterbury, the places where it gets cold in winter and the feed doesn't grow as well as it does in the milder north. The other thing that was interesting from this work was that less than 1% of our hill country agricultural land had been devegetated during this winter of 2018 and could have been considered at potential risk for erosion. And here's an example of one of our recent regional winter forage mappings that we've done for Environment Canterbury. Got two subscenes of Canterbury here. The one on the left is on the flatland around the Rakaia area. That's that white line going through the middle is the Rakaia River. And on the right-hand side is an example of a more hilly area around Lake Opua and Fairley. This is Lake Opua here, where I've just got the arrow there. And you can see now that we are able to distinguish between several more different classes of winter forage. We've got kale and brassicas showing up here in this map in blue. Fodder beet is red, and cereals are showing up in orange. Those of you that know this area will recognise that the south bank of the Rakaia River is an area of particularly good soils, and it's used for a lot of cropping. So there's quite a lot of bare soil here at the moment, waiting for the summer crops to go in. And on the northern bank of the river, where the soils aren't quite as good, there's a lot more pastoral farming and dairy farming going on. So what are we doing now? At the moment, while we are carrying out our starting our 2022 winter forage mapping, we're accumulating some more ground truth. We're trying to get a more generic set of spectral signatures rather than having individual sets of spectral signatures per image and per region. Ultimately, I guess what we're hoping for is one set of spectral signatures to rule them all, I guess you could say. Something where we can include the autumn and the winter imagery and be able to use this one single set across all our dates of imagery. We're also considering whether we should think about the FAST methodology that we tried last year, where we tried to get the information out to the users during the grazing season rather than waiting till the end of the season. And the other thing that we're considering at the moment is perhaps now that a lot of people are interested in the pressures that come on farms and the incidences of erosion and the worries about bare ground, etc., etc. Maybe we should be trying to look at producing a national layer every year. Thank you for your time. I hope I'm happy to answer any questions you have.
Hey, thanks for that, Stella. That was really good, and we're really short of time, but one quick one that we could get in there. Rest assured, anyone else who's putting questions in now or has got them in, we will come back to you with some responses, because there's some pretty tricky questions in there just now. But Stella, I wondered if you could tell us a little bit more about the atmospheric correction that you do.
I'd rather do that offline because it's not part of the methodology that I personally do.
Okay,
but
that's great.
It's based around the spectral bands of the Sentinel satellite. There are 13 different spectral bands on the Sentinel satellite, and 3 of these are used for calibration. One for the cirrus cloud, and the other 2 for atmospheric effects, such as water vapor. So there are algorithms that are run to do the corrections. I just personally haven't run them, so I can't give you bell, book and candle on that.
Great. This one's more of an applied question, and that's really just what are the wealth of different uses that councils and so on are putting this data to? Are they thinking about it in terms of soil erosion and freshwater quality, or is it really just monitoring the forage cropping for its own sake?
I think it's both, actually. One of the things that people are concerned about is the ability of bare ground, especially after an unfortunate rain event, to erode into local waterways. And so one of the things that people are really interested in is the proximity of cropping to waterways. And so I know people are being encouraged to think very carefully about where they put their winter forage crops, and to think very carefully about the order in which they strip graze their crop. Like if you had a slope, it's probably a good idea to start your strip grazing from the top of the slope and gradually work your way to the bottom, and other matters like that.
Great. Look, there's some fantastic questions there. We will come back to you all, and we really appreciate that. Thanks, Stella. That was a great presentation, and thanks to everyone for coming along for this afternoon session. We have 2 more webinars tomorrow. They're all listed in the original invitation that you will have received. So if you're fascinated by what we've been talking about already, come along for some more tomorrow. You'll be able to go back to that invitation and register for those if you haven't done already. But thanks, and we'll see some of you at least tomorrow. Bye for now.